Better late than never. Notes. Notes. Make a table for the following function and graph it. How come it all threw you guys, some of you, when you had x to the fourth? Some of you, it threw you because it was x to the fourth. You should be able to handle any power now. You know you've got the power up button on your calculator. You should have learned that in 8th grade, right?
Yep.
Okay, so don't let things like that throw you. All right, so it says here, x squared minus 3x minus 2, and we're going to graph it. All right, so let's just, because we have this little graph here, let's go with -2. Remember that this would be listed like this because I keep telling you function notation is going to be something you have to understand for this assessment. All right, more people get things wrong just because they didn't understand what was meant. So if it said f of -2 is equal to x squared minus 3x minus 2, you would want to put that -2 for the x and solve for your f of x, which is your y value, okay? So here is your y, here is your y, all right? So we've got -2, we're going to put in parentheses squared, and when you have a negative sign outside the parentheses, that's going to change your answer. Some of you guys got that one wrong on one of the homeworks. It was a negative, and you had to put a -1 squared or a 1 squared negative and a 1 squared. Okay, well, once you finish this, then this takes over, because remember, in PEMDAS, it's what? Parentheses, exponents, then multiplication and division. Okay, so this is -1 times 1, which would give you -1. So you only had 2 answers for that one, -1 and whatever the other answer choice. It didn't give you -1 and 1, okay? Because this is also 1, because if you put it in parentheses, then times the negative sign. All right, that's just kind of to let you know for that one. All right, never mind. -3 times -2 minus 2. And then I'm going to go to -1, 0, 1, and 2. I'm going to fill out my table first. -1 squared minus 3 times -1 minus 2. Parentheses, 0 squared minus 3 times -1 minus 2. And I just get in a habit so that I don't forget to put it in parentheses. I always put, when I'm squaring something, in parentheses, just like I talk about fractions. What?
Yeah.
Oh, sorry. Oops. See, I got distracted, and this is supposed to be a positive one, not a negative one. Okay? All right, and then I do 2 squared minus 3 times 2 minus 2. Okay? So my little table's filled out. Then I find my y values. You can put this in your calculator, probably the easiest way to go, but -2 squared is 4. Add 6. Subtract 2. Is that what it is? Oh, -2 squared is 4. Then we do this multiplication, and we get 6, positive 6. So 4 plus 6 is 10, minus 2 is 8, yes. All right. And we get 1 squared, which is 1. We get plus 3 is 4, minus 2 is 2. And 0 minus 0 plus minus 2 is a -2. And 1 minus 3 plus, or minus 2 is a -4. And 4 minus 6, which is -2, minus 2 is a -4, isn't it? Okay? And I'm going to take this one more place just so I get kind of a pretty picture of this. Okay? I'm going to go to 3 and 4. And if I did 3 squared minus 3 times 3 minus 2, and 4 squared minus 3 times 4 minus 2, I I would end up with 9 minus 9 minus 2 would give me what? A negative 2, right? And then here I'd end up with 16 minus 12 is 4 minus 2 is a positive 2. Okay? I believe that's correct. So now I'm going to plot. So I've got here negative 2, 8. I've got negative 1, 2. I've got 0 and negative 2. I've got 1 and negative 4. I got 2 and negative 4. I've got 3 and negative 2. And I've got 4 and 2. And if I really wanted to check my answers, I could put this in my calculator and go to y equals and clear it, come up here, and I could put in x squared minus 3x minus 2. It's in between things, so you use the minus sign. Only time you would use the negative is if it was out here, out in front. I set this one to 0, okay? And I would hit graph. And I get a nice little picture of a parabola. And I could do second and table. Oh, come on. Second and table. Did I freeze it? Nope. All right. And I could check. My y values are 8, 2, negative 2, negative 4, negative 4, negative 2, and 2. Right? Okay. I'm showing you guys the calculator before I usually show anybody else. So you guys are lucky. I usually make them do all this by hand. So now I can do negative 2 and 8. And I've got negative 1 and 2. And that's why I want you to show your work, because it's important for you to learn to do it on your own. And I've got 1 and negative 4 and 2 and negative 4. And I've got 4 and 2. And if you notice, yes, I've got a nice little parabola here. It's going to continue to go out and continue to go. What's my domain on that parabola? All parabolas have the same domain.
Oh, instead of all of them.
That's correct. What's the range? At this point, the only thing you know, because it does not show you where it actually comes to a point, okay, because it would be right for something is where it's going to happen. But for this, what it has marked on this graph, it would have to be what?
Negative 4.
What? How would you state that?
Y is greater than or equal to negative 4.
There you go. Okay, just checking. Okay, so is this relation linear? No. Explain. The graph is a curve, parabola, non-linear line. Okay? All right, now we're going to get into exponentials. Exponentials is something you use in a lot of science, because exponentials, when you hear a lot about it in growth and decay, we will do it as a whole unit near the end of school, like in March. March, April, we do exponentials, and we will learn about exponential growth and decay and how to quantitate that. Okay, like how many rats can be made from a pear in New York City in a matter of how many years? Oh yes. Okay. So here we go. Make a table and following functions and graph them. So we are going to do exponentials. In this case, you are substituting your x for your exponent, aren't you? Okay, so I've got 4 times 2 to the negative 2, 4 times 2 to the negative 1, 4 times 2 to the 0, sorry. 4 times 2 to 1 power. What is any number to the power of 1?
It's that number.
That number. What is anything to the power of 0?
0.
Oh, come on. I've said this many times. Anything to the power of 0 is the number 1. 250 to the power of 0 is the number of 1. 727 to the power of 0 is 1. Maybe I said it in my 8th grade class. I thought I said it to you guys. Anything to the, when we were doing, the first things when we were doing some exponents. Anything to the power of 0 is 1. Okay? So 4 to the power, 2 to the power of 2, and 4 times 2 to the power of 3. So if I put this in my calculator, I'm going to go back to here. 4 times 2 to the power of -2. Make sure you get out of exponent land by the arrow out key before you hit enter. And we get how much? 1. 4 times 2 to the power of -1. Get out of it, hit enter, you get 2. 4 times 2 to the power of 0. Get out of it, enter, 4. Because 4 times 1 is 4, right? 4 times 2 to the power of 1. I'm glad you're doing this with me and not just sitting there copying my answers. Is 8. 4 times 2 to the power of 2, or 4 squared, however you, 2 squared, however you want to put that in, is 16. And 4 times 2 to the power of 3 is 32. So, we are going to come down here and graph this. At -2, I have +1. At -1, I have 2. At 0, I have 4. At 1, I have 8. And that's about as far as I can go. And the thing about exponentials that you need to know is that this line will go and get as close to there as possible, but it will not cross the x-axis. You need something else in this equation in order to be able to cross the x-axis. So, it will get minutely close to the x-axis. Remember, there's an infinite number of numbers between 1 and 0. You just don't realize it because we don't deal with numbers like that. Well, and it is infinite, so it will get there close, it'll keep going, but it'll never cross it, okay? So this is known as f of x is equal to 4 times 2 to the power of x, okay? And that is an exponential function. Okay, let's look at this one. So, here I've got y is equal to 6 divided by x. So, I've got 6 divided by -6, 6 divided by -3, 6 divided by -2, 6 divided by 0, 6 divided by 1, 6 divided by 3, 6 divided by 6. 6 divided by -6 is -1. 6 divided by -3 is -2. 6 divided by -2 is -3. 6 divided by 0 is what? Put it in your calculator. Let's see what it is. Got an error message, didn't you? You cannot divide anything by 0. We call that undefined. Okay? 6 divided by 1 is 6. 6 divided by, okay, let me qualify this. 0 divided by 6 is 0. Okay? But you cannot divide by 0. 6 divided by 3 is 2. 6 divided by 6 is 1. So if I wanted to plot this, I'd have negative 6 and negative 1. Negative 3 and negative 2. I'd have negative 2 and negative 3. I'd have nothing. Then I would have 1 and 6. I'd have 3 and 2. And I'd have 6 and 1. Interesting. Interesting, isn't it? That's not an exponential function. Exponential you always have to the power of x, okay? Suppose you begin the year receiving an allowance, y, of 1 cent per week. Woohoo! 1 cent per week. Each week, you should make this deal with your parents, by the way, okay? They'll think they're getting the deal of the year. 1 cent per week. Make this with your parents, okay? Each week, x, your allowance doubles. This can be expressed as the function y equals 0.1, that's your 1 cent, times 2, which is doubling, right, to the power of x. X being your each week, okay? Complete the table and graph the function. So x is representing number of weeks, okay? F of 0, so we're going to do this, and we're just going to make a thing down here to put our f of x numbers or our y. This is our y value, okay? So we've got 0.01 times 2 to the 0 power. That would be week 1. 0.01 times 2, this is the next week. 0.01, because this is the starting point. You're starting here, okay? Don't forget that. You're starting here. This is ground zero. That's where you're starting, all right? This is the first week, because this is the ground zero. This is the first week. This is the second week. 0.01 times 2 to the third, 0.01 times 2 to the fourth, 0.01 times 2 to the fifth, 0.01 times 2 to the sixth, 0.01 times 2 to the seventh. Okay? So, we need to put this in our calculator and see what we end up with. So, Kate, what'd you end up with the first one? Are you Kate? What'd you get, Kate? Okay, 0.01. Since I know Denby here has already done the second one, what'd you get for that one? 0.02. Damien, what'd you get for the third one? What? 0.04. Okay. John? 0.08. Ooh, it's going up exponentially. All right. Hector, what'd you get for number 4? What? Mm-mm. It's here. 0.01 times 2 to the 4th. Okay. Luis, number 5. 0.32. Jalen, number 6. Ah, what is it doing? But what are these doing? They're doubling, right? Okay. All right, so what's going to be the last one? How do you double 0.64? What do you get? 1.28. So now we're going to graph it. When we were at 0, we were at 0.01, which is going to be like way down here, isn't it? Okay. When we were at 1, we were at 0.02. It's going to be just a little bit more. And then 2, 0.04, a little bit more than that, but not even quite halfway to 0.1. And then 3, we're at 0.8. Ooh, we're getting closer. Ooh, the 4th week we make more than a dime. Isn't that cool? Okay. All right, then we're making 32 cents. Woohoo! Then week 6, we're making 64 cents. We're getting to some serious money now. By the week 7, we are making $1.28. Do you see how it's starting to take a big curve up, isn't it? Okay, and it's going to continue with that nice curve up.
I think I might try to make this
Okay.
little mama.
Why is the graph only represented in the first quadrant?
Because you can't have negative weeks.
That's right. You cannot have negative number of weeks, or money for that matter, right? But this is first quadrant. Or negative, in this case, money. Okay? So you can't have a negative number of weeks, and they can't take the money. It can't start out in the hole, right? Unless you owe money. Okay? Would you like this to be your allowance?
Yeah.
What I want you to do is do it like this. 0.01 times 2 to the 52. So after a year, let's see how much you would be making a week. So let's see, we got 4 to the E13th, didn't we? Okay, I'll tell you what that number is. 0, 3, 5, 9, 9, 6, 2, 7, 0, 0, 0, 0. Because you would have to move your decimal point from where it is, because it says to the E13, right? You'd have to move it 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. So let's figure out how much money that is. Here we go. Here we go. Here we go. What do you think? So let's see, this is 270,000, right? This is 996 million.
What's that?
This is 35 billion. So you would make 45 trillion, 35 billion, 996,270,000 a week.
I'm gonna make that.
I'm doing this.
I'm gonna make that wager with my boss. I'll be like, all right, pay me
1
point
cent a
zero-
week and
yeah.
double it every week.
Yeah. He probably think he's getting the deal of a lifetime. I'm gonna go work at the Trump Corporation,
Yeehaw, huh?
and within a year they're gonna be